Yeah, welcome to this event here. This is my first time in Zaragoza. It's very nice weather, although in Göttingen it's also warm these days, like 26 degrees, which is unusual for Göttingen, as the Samba XP participants know very well. My name is Volker Lendecke, as you would pronounce it in German, but it seems very difficult, in particular also for English native speakers. Volker, that's mostly what you get. Yeah, I'm from Göttingen, as I said. I'm very long-term member of the Samba development team. I started in Samba patches in 1994, which is quite early in the Samba history. I will talk a bit about Samba history in the next few slides. So Zanet, one presentation about Zanet. We are roughly 60 people now. We have locations in, well, two locations. First, the main one is Göttingen, the other one is Berlin. We have three areas of activity. First is Samba. Then we have a big one with managed services, VPN, certification audits, and so on. And the third one is very nice, which is IT security management system, which is very popular in Germany these days because there is no official tool to get your BSI certification right now at all, and so you come to us. What do we do with Samba? We are involved in very many big European Samba projects. We have been in Munich, we have been in Berlin with the Bundestag, we have been all over Europe, we have been active in the EU versus Microsoft case. We are essentially, when you want to have file server development, we are the only one who is independently available for development. This slide is slightly outdated. We're not the only available commercial development resource anymore. You can go to Andrew Bartlett in New Zealand, so the Samba team really covers all time zones. Andrew is more focused on Active Directory. We are really focused on the file server clustering stuff. What we provide is, so if you have a Linux distribution like Debian, RHEL, SUSE, typically you don't get the latest up-to-date Samba versions on the enterprise distributions. You do get bug fixes, of course, but if you need fancy new features on your RHEL 6, RHEL 7 or whatever, then you need RPMs, more recent ones, and this is what we provide to you for free. And then, as I already mentioned, we have a annual Samba conference. I think it's 15th one now, something roughly like that. It is in Göttingen next week. Almost everybody of the Samba team comes there, all the active developers. Microsoft recently has started to get big in the Samba XP. Actually, Microsoft is sponsoring Samba XP, which is really rhymes into the theme that Microsoft is into open source these days, which is great. Okay, quick overview of what is Samba. It's a free implementation of some of the Microsoft protocols. It's an SMB 1.3 server. We started out with just SMB 1 because, I mean, SMB 2 was not even started to be invented when we started in 90-something. The historic foundation, what we still do today, is NetBIOS over UDP and TCP. Anybody ever read RFC 1001 and 1002? Chris, hey! We still do that. Microsoft still does it. I'm not sure about how many Win server implementations are still around. NetBIOS Datagram Distribution Daemon. Has anybody done that? Do you have an implementation of that? OS2 does? Okay. Question was, what is OS2? Second big piece that we implement is the Microsoft for us important piece of the Microsoft RPC services. What is RPC? It's essentially remote management of Windows servers. It's the foundation of Windows domain services. We implemented a Windows NT compatible domain controller based on top of Microsoft RPCs. Essentially, that's DC RPC with new security enhancements and new transports when you look at the implementation from 96 and NT4 and before. Contrary to popular belief is these RPC systems are still very, very much in use even in Microsoft Active Directory these days. NetLogon is still extremely important, and all this Windows management infrastructure stuff, that's all based on RPC, at least partially. Samba implements its own LDAP server. We have a sad history of not invented here syndrome, but for this LDAP server we have a reason, because at the time when we started to do the Active Directory services, it was very difficult to get Active Directory specific extensions into the open LDAP source tree. These days probably they will be more open to these changes, but at the time when we needed them, they were very strict in adhering to the LDAP standards, and they were not really open to the extensions that Microsoft has made to the protocol. Kerberos, we implement that protocol. For Active Directory services, we use the Heimdall KDC right now. We are, in particular, Red Hat is big on, and probably Simo will talk about that later. In particular, Red Hat is putting many resources into also supporting the MIT KDC, possibly at some point replacing the built-in Heimdall KDC. We implement DNS in two flavors. So an Active Directory client requires DNS to work properly. So we have to do something about that, and we have two implementations of DNS. The first is, historically the first was of course a Bind plugin, but Bind also has a tricky API to plug databases into, and to make deployments easier for users. We just implemented the pieces of DNS that are strictly required. So we have our own DNS server that is not as capable, of course, as a full internet. You wouldn't want to put a Samba integrated DNS onto the internet, but it does enough for Active Directory domain services. Second very important component of Samba is Windows domain client. So if you want to deploy file servers, if you want to deploy Linux clients or FreeBSD or whatever clients, usually if you go to customers, they have an Active Directory. For the better or worse, Active Directory is a given these days. And if you want to go in with Linux clients, you have to authorize against this authorization source. So Samba has implementations for these protocols as a client too, which means, okay, we can accept Kerberos, we can accept NTLM logins coming in from clients, of course. We have a separate component in Samba that's called Winbind. This essentially takes care of all the domain membership tasks, which is, okay, to authenticate, from time to time we need to locate a domain controller. That's a surprisingly difficult task. Winbind does it for you with DNS and CLDAP site-aware requests. Also, from time to time we have to change a Winbind or workstation password with Active Directory. Otherwise, some script in Active Directory will just remove our entry and we can't authenticate anymore if we don't change our password as a machine for weeks. And the most difficult piece in practice is the identity mapping. So what's a Windows user? Essentially, a Windows user is a 128-bit ID. So is a Windows group. So is a Windows computer. So is a Windows printer. Every object that you can put into Active Directory has a so-called security identifier, which is essentially a 128-bit large identity. Under Unix, we have the problem that a user and a group typically is 32 bits long, And you can't really squeeze bidirectional 128 bits into the 32 bits, so you have to do some active mapping here. And Winbind has very flexible interfaces there. First, you can store your your Unix identities in Active Directory. You have to explicitly enable this in Active Directory. But also we have the ability to statically assign ranges. This domain is from 1 million to 2 million in local in our local attributes. That domain is the next million chunk, and so on. You can even fork scripts if you have some custom mapping. Universities are really used to this. They have some separate source for Unix identities that might be name-based, that might be with some weird mapping. You can call out scripts when a new SID comes in. What Unix identity do we have to assign to this SID? And then another feature is, okay, when you are a member of an Active Directory domain, you take your laptop home, you want to work at home, you don't have access to your Active Directory, how do you locally authenticate? Windows has a facility to do offline logon if you have logged in successfully once. And Winbind can do this for you by storing your credentials locally on disk. And so you can re-authenticate. So, when did Samba start? In 91, 92. So the next few slides are essentially stolen from resources on the web. So, when you look at Eric S. Raymond's book Cathedral in the Bazaar, there's a quote, "Every good work of software starts by scratching a developer's personal itch." Andrew Tridgell in around Christmas 91 had a problem. He was sitting in a university, and he had files living on DEC Pathworks servers. Anybody remember DEC Pathworks? And also other files on SunNFS. But it was 91. The internet didn't really exist at that time. And so everybody brought his own TCP IP stack to MS-DOS. And as you could guess, PCNFS and DEC Pathworks had incompatible TCP IP stacks. So what he had to do is, when he wanted to access DEC Pathworks files, and after that access SunNFS files, he had to reboot and change his config.sys to load different drivers. Yes, Chris? His comment was that DEC Pathworks might have run on DECnet, but from reading the history file in Samba, I guess that yeah, okay. They might have been compatible, but then you got 600K. Probably you couldn't just squeeze both implementations into that memory. So, and famous last words: how hard can it be? Still revolving these days. How hard can it be to make the Sun speak the Pathworks protocol? And as he just continued doing that for many, many years, he just looked at network packets. He looked for common patterns and a lot of magic values he put into his server 0.1 implementation, and suddenly he could use the DEC Pathworks client stack to access files on his Sun workstation. Great! Much, much later figured out that Microsoft with its client also uses this protocol, and there's even a real RFC. As I mentioned earlier, RFC 1001, 1002 essentially provides the basic framing of these protocols, and even in latest SMB 3.1.1 you still have the length field according to this RFC 1002 padding, whatever frame definition. So even in latest protocol you still have some RFC 1002. So this is about protocols, and also this is not really my invention. Tridgell, when being asked how do you develop Samba, there's a lot of rumor about reverse engineering, and if you ask a lawyer or even a judge reverse engineering is evil. You don't do that because this violates copyright. And it's even a crime in some legislations to look at object files delivered to you via Windows Update, disassemble them, and see how it works. This is not what we do. This is not what we have ever done. What we do is we use this French cafe technique. People talk to each other, and we just put up a microphone. We listen. And we just put up a microphone, which is called network scanner these days, network sniffer, and we see what they talk, and we see what they speak. His analogy is really the French cafe. You are sitting in a French cafe. Oh, you're German, Spanish, American. You speak no word of French. How do you want to learn? Go to France, sit in a cafe, and listen. Listen to the people who order something. You put on the words, and you look at what arrives later on. And as I said, in a French cafe, croissant, coffee, milk might be very obvious words very soon. You just listen and you try to repeat this. And maybe it works, maybe the waiter will not understand you, but at some point you get enough exercise, enough training, that you actually get a café au lait. And I'm really pronouncing this like Volker Lendecke, but you get some coffee with milk. So what we can do is we can just listen to what Windows clients talk to about with Windows servers, and we can do the same. And yeah, but passive listening just limits what you can do, because this only makes you see what real Windows clients do, not what a Windows server could do. And this, by the way, is still a problem for many implementations of SMB. There is one, or at least one, very popular SMB implementation which shall remain unnamed, but they say we only do what Windows clients will do to us. We had so many support cases with that implementation coming from a Linux client where the vendor said, no, this is not on our support list, go away. We will not implement this feature, even if we prove to them that they have security holes with this particular SMB request. And yeah, they just do what Windows does, and this is on their support metrics. Linux and SMB client and so on are not. So go away. Okay, next step. You start poking the waiter in the eye and see what happens. And yeah, try ordering something in a French cafe yourself, poke the waiter in the eye, step on his toe, and you learn error codes. Create a file that already exists. Create a file with a silly file name which Windows wouldn't allow. Do other weird things. Just, try to authenticate with password wrong. Do you get an anti-status, access denied, anti-status, whatever? What do you get? Essentially, you start writing your own client and do nasty things, and this way you can learn error codes and different behavior. And this is still what we do these days. Third one is you can do protocol scanning. At some point, once you have learned a bit of the protocol, you see, okay, byte 39 or so, that must be an SMB command. Whenever people try to create a directory, they send 5 in this field. Whenever try to read a file or read a block of some file, they send 20 here. And this is usually a 1 byte, 2 byte. In SMB2, it's 4 bytes these days. Just try all values. This is not mine. Just try all values. And yeah, just see how the Windows server behaves. By the way, this is a technique to do security scans. Still these days, what you call network fuzzing, that's what it's called today. And it's always funny, you can still crash servers by just doing fuzzing. I wouldn't say that you can't crash Samba. It's very rare these days, but it still happens. If you just send garbage, that you will find crashes. The one thing that is really, really difficult to get is once you start cryptography. So you only see encrypted blobs, you only see some hash values of something. This is really, really difficult to do if you don't know anything. And yeah, you have some ideas that any sane implementation would use standard protocols. I mean, early authentication protocols were based on DES. But even if you say, okay, I know that is data encryption standard, there's so many knobs you can tweak, initialization vector, padding, and all that stuff. That's really difficult to figure out. And this is where the time after, in 2007, times really, really changed for the better. So in late 2007, I didn't really, Daryl, do you know when you really dropped that to MSDN? I didn't find that reference. That was to spring 2008? No. In September 2007, the final EU decision was made. Even before? To the public? I don't know, but yeah. Yeah, I couldn't find that. But so what happened is, there was this big EU, at least from our perspective. You had your own Department of Justice case before. So there was a US-based program protocol which was called, that was not WISP, that was the other one, MCPPE. So you could get access to Microsoft documentation, and from Samba's perspective, with the EU Commission's decision to make Microsoft open up its documents, it really changed. We have the Protocol Freedom Information Foundation, which made a contract with Microsoft, and so we had pretty early access to all these documents in their current status at that point. A bit later, Microsoft just dumped everything to MSDN, and yeah, now you can really look it up on the web. Just Google for MS SMB2, and you'll find a several hundred-page document. Google for MS FSA, MS DTIP, or whatever. So many documents out there. Most of the guessing was gone. In particular, what really made the difference is we didn't have to really guess anymore what crypto algorithms were used and so on. We already had figured out most of the SMB2 protocol, but I mean, having official documentation really changes things. However, this French cafe thing is still very important to us. Because, I mean, MS SMB2 is several hundred pages, and it depends on so many other documents. One of the biggest one is MS FSA, file server algorithms, which is essentially NTFS semantics as seen by file server implementations. And the Microsoft implementation of file server is much smaller than Samba's is, because they can rely on NTFS to do some correct things for them. We have to implement most of that ourselves. So to figure out error codes, to figure out specific behavior, timeouts, timing behavior, and so on, it's a huge amount of documents that you have to go through. And if you have a very specific question, how does Windows behave in this and that situation? It's very often it's just quicker to fire up SMB Charger, write a quick test, and see how Windows actually behaves. And then, of course, documents are complex, and they still, of course, as any document, they are not perfect. They have errors. Thanks to all the people, Obaid and Edgar, we have a process to get document improvements, to ask questions. But I mean, they are very responsive. When we show them a network trace, this contradicts to what you have documented there. We will get updates to the documents. But again, this French cafe technique is still important. Poke Windows in the eye and see how it behaves. And if you have it in code, we can always run it in our regression test suite. So putting this behavior into SMB torture is still important. So what's the current status? SMB1, I would say, is as complete as possible. There's so many flavors of SMB1. I wouldn't even want to start counting the number of SMB1 server implementations that all behave slightly different. And I guess that's one of the main reasons why Microsoft eventually chose to get rid of that protocol, because I mean the test matrix must just be huge. And a recent bug somebody reported to the mailing list. You take SMB client, you list a directory from an OS2 server implementation, and it strips file names. It strips the first character of all file names when listing directories. So OS2 is still around. And I mean, yeah, we do what we can do with SMB1, but there's so many flavors of it. Recently, I had to go into a customer, huge steel factory. They have machines that still are run by Windows for Workgroup 3.11. Samba works fine with Windows for Workgroup 3.11. So that's a pretty good indication that you can say SMB1 is really pretty much complete. SMB 2.0, 2.1, almost complete. The one feature that is missing is resilient file handles. That's the initial attempt, or one of the approaches Microsoft has taken to provide failover when a network connection dies or when a server dies. Microsoft has told us that once you get persistent file handles, don't even start looking at resilient file handles. It's not going to be necessary, not going to be relevant anymore. So once we got persistent file handles, yeah, this feature of SMB2 is not worth pursuing. It might be there, it might be important for completeness, yeah, but it has been superseded by persistent file handles. Correct me if I'm wrong. SMB3, all mandatory features are done. SMB3 is a, yeah, pretty major revision of the protocol. It was initially called SMB 2.2, but because the changes were so significant, they say, okay, let's go SMB3. All mandatory features means we have all the security stuff, AES-based signing, secure negotiate. Yesterday at dinner time, Obaid asked me, okay, do you do the latest SMB 3.1.1 thing? And yes, we do. Not with released versions, but it went into master last or the week before last week. So we follow what is required pretty closely. And what I always find surprising is if you want to get transport encryption with your SMB share, in Samba you just say SMB encrypt equals yes, and you're safe. Or you're safe in the sense that nobody on the wire can look at your data anymore. That's really, really easy to set up these days. Assuming you have Windows 8 clients. Windows 7 won't do that. The main data features, data center features that have made Microsoft call this protocol SMB3 and not 2.2, we're not there yet. Multi-channel we have a prototype for, but it's a matter of integrating it. SMB Direct, that's RDMA. That's essentially RDMA requires good kernel level infrastructure, and it's not really. So we haven't really found a good implementation in the Linux kernel so far that does what we need. So all the RDMA support that we have found in Linux kernel, for example, can't live with processes doing fork. Samba is really great at doing fork, so we have to find ways around that. Maybe we have to re-implement parts of the RDMA stack ourselves, which is really a pain. But fun. Oh, sorry, RDMA, remote DMA. It's essentially offloading all CPU cycles that come with transporting a byte from machine A to B to whatever, a network card. So you just say, okay, these 10 megabytes, please ship them to that machine and tell me when you're done, and the CPU cycles are free. The CPU doesn't have to do anything with it. It's remote direct memory access. It's a programming model where you can say, okay, this piece of memory is equivalent to that piece of memory remote, and the main reason for to do that is transfer of bulk data essentially becomes free from a CPU perspective. InfiniBand is one of the most well-performing implementation of that. It's just faster transport. It's a replacement for TCP. Much faster implemented and much lower latency implementation for TCP. And the other one, persistent file handles. That's the two big data center features that Microsoft advertises. You don't want your C drive in a Hyper-V guest to just drop or give I/O errors if the when some network connection drops. And so this is what persistent file handlers are for. We have all plans. We're not there yet. How much time do I have? Okay. Jeremy Allison once, a Samba developer, just said, once said, this protocol is so big you can drive a truck through the holes in it, nobody will ever notice. So, and this is what Apple made use of. Apple in their implementation, Apple focuses on SMB for file services now. Apple used to have the Apple file protocol in OS, Mac OS 9 and before that. And with latest, or with something like 2 years ago or so, they started preferring SMB2. And what they did is they extended the protocol. If you look at what a typical Mac user does, they love to create file names that contain a slash. They love to create file names that contain stars and colons, all the forbidden characters under Windows and Unix. And yeah, if you want to have a compatible Mac to Mac implementation of a file server protocol, you have to map these characters. Some time ago, Ralph Boehme joined Zanet. Ralph Boehme is the main author of NetterTalk, which is essentially Samba for the Apple world, because he saw the signs on the wall that the business model around NetterTalk will shrink in the future. And what Ralph did was he implemented VFS Fruit, just to avoid trademark conflicts with Apple. We called it Fruit, which is essentially two things. First is, so Apple stores resource fork, finder metadata via AFP and via SMB. And if you store it via AFP, NetterTalk has its own way to store this data. And what you expect if you have both AFP and SMB implemented on your server side, it shouldn't matter whether a client now comes in via AFP and tomorrow decides to go via SMB. You want to see the same metadata. And what he did is in VFS Fruit, essentially he created the same name mangling and the same metadata storage that NetterTalk uses for Samba. So it should be transparent now. If you have whatever 1,000 Macintosh clients, 100 of those still come in via AFP and the other ones concurrently access the same files via SMB. They should see the same data. The other one is Apple has extended some info levels in the SMB2 find command. What they did is, so the main problem with Finder is if you have a directory with 10,000 files over a wide area network, what Finder, which is the Microsoft Explorer on Mac, so essentially the file browser, if you click on that directory, what it does is it lists the files, and if you go via SMB, for every single file it tries to open the metadata in 2 attempts. First the Mac Finder info and then the resource fork. And the bad thing is it does this synchronously, which means request, response, 10,000 times, and it doesn't display anything in the GUI before everything is finished. Windows is better at that. Windows starts to fill in the preview when it gets data, but Finder is really bad. And what Apple did with the APL extensions is they just implemented, or they just sent the information that the Finder with back and forth, open, close, request tries to query very slowly. They just send it in the first rush. And that's the APL extension, and this is what we do with Samba now. Do you plan to implement that in Windows? it's really, I mean, you get several orders of magnitude performance when you want to store information. When you have large directories over a wide area, this is really the showstopper. Yeah, that's what we do with OS X clients. So, what's the current status of the Active Directory? This small business server I would really, without any doubt, sell to any customer, which is single DC, single domain, whatever, 50 users, 100 users, and so on. The pure directory replication works fine. However, what we don't do is we don't replicate the sysvol share on a Windows DC automatically to Windows. This is what you have to take care of manually with rsync or other protocols. This makes it difficult, however, to have a mixed Windows and Samba domain. Just for this, I mean, the pure directory objects, the users groups and everything else, that just works fine. It's the sysvol share, which is important for the functioning of a Windows domain, that is not automatically replicated. Eventually we have to get there, but it's not there yet now, right now. Who knows what the KCC is? Our KCC implementation, which is essentially the software component that decides which domain controller replicates what data when with which other domain controller. That's very primitive. Just replicate everything everywhere. This is quite primitive these days. There is right now work underway that improves this work and make it smarter. Yeah, but this makes it a bit difficult to have a large number of Active Directory domain controllers based on Samba. Then we haven't really tuned our LDAP server for size, and yeah, we have to work on that. An alternative approach that is currently underway, I don't know about the status of it. The Simus Corporation, which is the main developer of OpenLDAP, they are trying to get OpenLDAP, the OpenLDAP engine, usable by Samba, which really would give a big boost in scalability. Domain trust, I guess Simo is going to talk about that later. That essentially works fine. If Samba wants to trust another domain, we have some integration work to do. But if another domain wants to trust Samba, that basically works. But outgoing trusts, they just need integration work with Winbind and whatever. Clustering. So we have a clustering implementation. I think we have been ahead of Microsoft. This is one of the very few fields where we are ahead of Microsoft with an active cluster that presents a full multi-homed SMB server essentially over different nodes. There's products around that. Thank you, 5 minutes left. We have implemented our own cluster log manager. Yet another not invented here syndrome. But at the time we started this, no other clustered log manager was widely enough accepted and functionally complete enough for us to use. So we have implemented our own cluster manager and cluster database log called CTDB. CTDB these days does way too much. It does log coherency, service monitoring, IP failover, cluster membership, whatever. It's way too much. We are on our way to restructure that to play better with others. Certain components will be very difficult to replace, like the pure database management, but maybe somebody eventually will also replace this. Yeah. So what you can do with Samba is you take one of these cluster Ceph, GPFS, StoreNext, clustered file systems, put Samba on top of that, and export the same file space via different nodes. Yeah, CTDB now is part of Samba as of Samba 4.2, and we will have better integration there. Yeah, what's next? We have a wiki where all the SMB3 features that are implemented and which are still missing are listed. Yeah, we need all these data center facilities, multi-channel persistent file handlers, RDMA. We are going to implement the MIT KDC support pretty soon, I guess. And as I said, improved clustering makes CTDB play well with other clustering components. Essentially strip down CTDB to what really is required. And as always, performance tuning will never ever end. We will try to tune Samba to be much faster. We have an interesting spectrum. We have the tiny boxes like whatever network enabled hard disks, which have almost no CPU, very little RAM. We have to play fine there. Then we have the very, very big data center, whatever multi-rack Samba implementations, and we have to also scale there. It's an interesting spectrum where you have to scale, and there's different performance problems at both ends of the spectrum that you have to tune for, and yeah, it's still interesting. Other questions? That's an advertisement for chocolate, by the way. Not a trademark violation. Yeah, any questions? Otherwise, I'm going to be around over lunch, and I will have to leave tomorrow, so if you have some more questions, it needs to be today.
I have a question. Looks like I'm the only one curious here.
I just wanted to say that KCC stands for Knowledge Consistency Check.
Yeah, okay.
Yeah, so I have a question. It was very interesting, the French cafe technique, and it was also interesting to see that somebody is still using it, even though the protocols are now open and documented.
Mm-hmm.
I can assume that it's a big effort to implement all those tests. And my question is, now that the protocols are open, if you need to start all the Samba implementation from scratch, would you still implement those test suites, or would you go directly for the implementation of the protocol?
That's actually a good question. I mean, with all this, whatever modern development schemes, test-driven development, continuous integration, and so on, you need a good regression test suite.
Yep.
And the gold standard for our regression test suite is the latest Windows release. And so we have to implement all these tests anyway. Because when you make a change, you really need to run all the complete test coverage against your current implementation.
Mm-hmm.
So we would probably, our tests would look a bit different, but a bit better organized. I mean, this is really our backyard, whatever, our attic, where we don't really look for code quality. It just has to run. And our tests would look more organized, but we would still, of course, have them.
Mm-hmm.
Another question?
Almost a question. I wonder if we could say it might look different implementing from scratch if we could work from the protocols, and Microsoft did too.
Won't work.
Right, but that would be the theoretical wonderful thing. It's lovely that the protocols are published, but unfortunately the real world considerations are rather different. It is wonderful. It's been a huge help, hasn't it, Volker?
I would be curious to know how the Azure team approached this problem.
So it's interesting because one thing I want to say about Azure is it is an implementation of the protocol. Obviously, they
Client
are
side, right?
It's server.
Server side, okay.
Yeah. So the Azure server is an implementation. I mean, obviously there are considerations they have access to. It was built upon. Azure has been built upon Windows, but it is not Windows.
Mm-hmm.
So it is an implementation of the SMB2's protocol specification.
Not entirely clean room, looking just at the documents, probably,
Right.
but
Right, but it is an implementation. It's not.
I mean, in the history, so there have been many competing implementations, or there are of course, many competing implementations. Some of them being open source, some of them being taken closed. I mean, one of the more popular ones is the Likewise implementation that via 2 acquisitions ended up with EMC, and now it's closed again. You should ask them how they approached this. To be honest, I don't know. I mean, from looking at the docs, okay, you have how many pages is SMB2? 500? Whatever, something.
Yeah, it's greater than 500. It's less than 1,000. I think it's 7.
It's very big, but
Yeah, I got it here, but
Yeah, I mean, it's how does it compare to NFS v4? I mean, it's roughly in the same order of magnitude, and yeah, and people have started cleanroom implementations from NFS v4. So, from looking at these 500, 700 pages, it might seem manageable,
right.
but the devil is really in the details. Once you start beating the implementation with Microsoft Excel, I mean, then really shit hits the fan, to be honest.
Right.
And with all the fields, I mean, you really, if you want to go to the implementation clean room from the documents, you have to really implement every single line of those 700 pages.
Wow.
Yeah.
Yeah, and that's
And there's timing, and then there's character sets, and
yeah.
there's random cosmic rays.
Any more questions? Then I think lunch should be open soon.
Yes, that's correct. Thank you, Volker.
You're welcome. Thank you.
Yeah.
Volker.